Hello everyone, in this video I'm going to show you the scheduler of ToroKernel, and to do that we're going to program a user application in which we're going to create some threads and see how they are scheduled by the ToroKernel scheduler. So first we're going to create an environment for that. So to do that I have a Docker files that we can get it from the website. Then I'm going to, I think I have two here. Yeah. So I want to just remove this one. Fine. So now we're going to build the container and then going to run in. Okay. We are in the container. Now we can go to the examples. So for example, let's go to the hello world example. To try, we can just call Cloudy, which is in script to do that. And then we pass it the hello world. So we see how it compiles and then it executes. To execute, it uses QEMU and KVN. So if you want to exit from QEMU, we can just do Control A and then see. Well, we get the monitor and then we write quit, and that's all. So now, in order to create our application, we're going to use the Hello World example as a template. So I'm going to create a directory called scheduler, and then I'm going to copy some files that I needed to compile application. That's it. So let's see the code. Yeah, I don't have Vim in my container, so let's just install it. Cool. So let's just open it. Well, here we can see the Hello World example. First thing I'm going to do is just to to change the name of the program. So I will call it scheduler. Then I'm going to keep the modules that I require to include because it's going to be the same modules. And let's first change the hello world message by something that tells us that the application has booted. So I'm going to write something like starting thread. So now we're going to define a function that's going to be executed by the thread. So let's call it function thread param pointer, and then it's going to return an int. Okay. Well, that thread is going to do something simple like a loop, an infinity loop. We don't care too much about the indentation for the moment. And in this loop, we're going just to print something in the screen. So write console f hello from we're going just to print out the parameter. So that's it. So yeah, I think well we have to next create the thread. So to do this, we're going to call the begin thread function, which I don't remember exactly the parameters, but I think the second one is the size of the stack. The third is the function, which is thread. The fourth is the argument. Now it's just a null pointer. The next one is the core in which the application is going to run. Since we are trying with only one core, it doesn't matter too much. So I'm going to just set 0 and TMP, which is the thread ID. I have just to define the thread ID. And here we have to write thread ID. Yeah, that's it. I think we're done now. Yeah, let's just compile to see what happened. So again, we call it with the scheduler. Okay, well, at least execute, which means that it compiles well. But then we only have the message for the main thread, which is a starting thread. Let's see in the code what is going on. Well, the problem is here. What is happening here is that the loop holds the core, and since the scheduler is cooperative, we have to tell the scheduler that it can schedule a new thread. So instead of holding the core, we have to call the scheduler here. And to do that, we use the thread switch function. Let's save it and exit and compile again. Okay, we have the thread printing on the screen, so that is not bad. Let's just add a second thread. To do that, we have just to duplicate this line. So instead of putting 0 here, we put 1 to identify the second thread. This is still fine in the sense that we are printing only one thread, but the second thread that we just created is not being scheduled. So let's see in the code what is going on. Well, I think the problem is here. What happened here is that the thread is going into a loop, and since the thread is not invoking the scheduler, it's staying this core forever. As I said before, the scheduler is cooperative, so we have to call the scheduler when we're done. So let's add that at the end of each iteration. Okay, I think we're done now. So let's just compile it, running, cool. So we have the two threads that are executing. Let's create a third thread to see how the scheduler schedules this thread. And to do this, I'm just going to duplicate this line again, and then change the ID. Let's compile it. Okay, cool. We have the three threads. If we stop the simulation or the execution, we can see here that the threads are scheduled exactly in the same order in which they are created. And this is because the scheduler in Toro is very simple and it's only a linked list in which once the thread is added, is going to stay in the same position forever. And this is also a special case because these threads are not doing I/O, but even if they are doing I/O, the position in the list is always the same. So what happens when the three threads are ready? They are going to follow the same order in which are created, and this make the scheduler very deterministic because also the way that the scheduler is implemented is just by choosing the next ready thread. And to do that is only an O1 operation. I hope you have enjoyed the presentation. And if you want to reproduce this, you have just to go to the ToroKernel website or GitHub and then get the Docker and write the example. Thank you.